Now we are going to discuss about classification of signals. So before that we should know what is meant by signal. So the signal is nothing but it carries some information from one place to another. So it can also be defined as a physical quantity that varies with time. So the temperature, pressure, or with any independent variables such as speech signal or video signal. So the signal means it carries some information from one place to another, and it can be represented or it can be varies with time. So speech signal or video signals are the examples of the signal. So now we are going to discuss about classification of signals. So we have 5 types of signals. First one, continuous time and discrete time signals. Second one, deterministic and non-deterministic signals. Third one, even and odd signals. Fourth, periodic and aperiodic signals. Last one, energy and power signals. So first one, continuous time and discrete time signals. So a signal is said to be continuous means it will be defined for all instant of time. So here this is the continuous signal, so it is the time. So in x-axis we have the time and y-axis we have the amplitude. So it's having amplitude at all instant of time. At all instant of time the signal having some amplitude, or the signal is defined for all instant of time. So that is the continuous time signals. Second one, discrete time signals. So the discrete time signal means a signal is said to be discrete when it is defined at only discrete instant of time. That means the signals having the amplitude at the some discrete instant of time. For all the instant of time it does not having the amplitude, it does not having the magnitude at some discrete instant of time. That is the discrete time signals. Next one, deterministic signals. So the deterministic signals means a signal is said to be deterministic if there is no uncertainty with respect to its value at any instant of time. That means this is the deterministic signals. At any instant of time there will be no uncertainty happens to the signals. Means the signal varying like this. There will be no uncertainty happen, and the signals can be represented by the mathematical formula. So we are calling this is a deterministic signal. And non-deterministic signal means if there will be having some uncertainty will be in the amplitude of the signals with respect to time. So we are calling this is a non-deterministic signals. So the non-deterministic signals are random in nature. So we cannot described by some mathematical equations. We cannot described by some mathematical equations. So they are modeled in probabilistic terms. So we are calling this is a non-deterministic signals. Next one, even signal. So the even signal means a signal is said to be even when it satisfies the condition. So what is the condition? X of t equal to x of minus t. So this is the condition for the even signal. X of t equal to x of minus t. So here this is the example that x of t equal to t2. So here instead of t we are writing minus t. Means so minus t2. So you will get t square, not t2, this is t square. So minus t square means the answer will be t square. So we are changing the we are giving some negative sign to the time, but it will not change the magnitude of the signal. Okay, so that is the even signal. If there is any change in the time value, it will not change the response of the signal. It will not change the value of the signal. So that is the even signals. Next one, odd signal. A signal is said to be odd when it satisfies the condition x of t equal to minus x of minus t. So let x of t equal to sin t. So we are changing the time value. We are giving the negative polarity. So minus t means sin of minus t minus sin t. So we are giving the sign changes to the time axis, means it will change the signals. So that is the odd function. Next one, periodic signals and aperiodic signals. So a signal is said to be periodic, means if it satisfies the condition x of t equal to x of t plus t, or x of n equal to x of n plus capital N. So here t is the fundamental time period and 1 by t is the fundamental frequency. So here this is the original signal, and x of, so this is t known is the time period. So for all the, through the waveform, the time period will not change. So we are calling this as a periodic signals. So here the same interval repeated again and again. Okay, so we are calling this is a periodic signals. So aperiodic signals means if it does not satisfy the condition x of t equal to x of t plus t or x of n equal to x of n plus n, means if does not satisfy the condition, we are calling the signal as aperiodic signals. Okay. Next one, energy and power signal. So energy means a signal is said to be energy signal, means it's having some finite energy. When you are, so it's having some finite energy, it should not be infinite. So that is the energy signal. Energy signals means the energy value will be finite. Okay. So for energy calculation, energy E equal to minus infinity to infinite x square of t into dt. This is the formula for the calculation of energy. Next, power signal. So a power signal, a signal is said to be power signal, means it has some finite power. Normally the power signals having some finite power. So it will be represented by power P equal to limit t tends to infinite 1 by 2t integral minus t to t t x square of t into dt. Okay. So these are the classification of signals. Thank you.